Mr. Basavaraj, are you there?
Yes, sir. Yes, sir. Can you
Yeah,
able to hear
please, sir.
me?
Yeah, I'm able to hear you. Yeah.
Yeah. Is the screen visible, sir?
Yeah, it's visible. Please go on.
Yeah. Yeah. Thank you very much to STI for giving this opportunity to us to present our case. And today I'll be talking on our unique proposition for the CBG projects, especially for the sugar industry. So, in the content, I'll just a couple of slides on the corporate information and followed by the technology and value proposition. So, we'll enter into the subject. So, just to give facts at glance, so last year we have been honored with the George Washington Carver Award for the innovation in the industrial biotechnology and agriculture to our founder chairman, Dr. Pramod Chaudhary. So, as all you know, we are a 38 years old company with a revenue of about 150 million, and we have about 750 reference worldwide. Out of that, 350 are overseas, and we have about 1,200 employees working in all disciplines. Out of that, 60% are chemical engineers and more than 90 research scientists working in our R&D center. We have more than 300 patents in our name in our different technologies. So we have almost 6 business verticals operating, and this bio-CNG or CBG comes under bioenergy business vertical. So where 1G ethanol from molasses and grain, and the second generation ethanol from the biomass is a part of bioenergy. And other than that, we have engineering business units. We set up brewery plants, critical process equipments, and the environmental business to cater the niche effluent treatments in terms of zero liquid discharge, and high purity systems, Praj high purity system, which is catering the pharma and biotechnology space. So to all these business units, we have been supported with the Praj Matrix R&D Center, which is an DSRI certified R&D center, and I mean more than 25 to 30 million capital investments. So where this is the first of its kind R&D facility where we have bench scale, pilot scale, and the demo scale infrastructure available for the process technologies which we commercialize it. So Praj's BioMobility Platform, CBG is part of the BioMobility Platform. Likewise, as you know, the e-mobility, so biomobility plays a vital role where there is a direct contribution of biofuels to the transport sector, which can reduce the carbon footprint, so which has minimum GSG reduction. So other than biofuel, I mean other along with the CBG, other biofuels like bioethanol, cellulosic 2G ethanol, biodiesel, SAF, sustainable aviation fuel. So these are all comes under biomobility platform. So which will facilitate the sustainable decarbonation through circular bioeconomy. So with this entering to the subject, compressed biogas plant from the sugar industry, especially we are talking about the press mud, bagasse, and the spent wash. So as Sanjay Patil already briefed about the economics and all everything about it. So one thing what I would like to say ki the raw material availability for it to set up any industry, the first primary requirement is availability of raw material at one single point. So in other cases, like when we talk about agri residue, municipal solid waste, or cattle manure, the raw material is in a scattered form, When it comes to sugar industry, the raw material availability is at one single point location. So what we feel that the sugar factories and the distillery attached to the sugar factories are sitting in a very good position to set up or to go for such projects. Okay, so along with the press mud treatment, we are also working on the other biomasses like bagasse, rice straw, wheat straw, and all. So if you look at the overall potential available is about 16 million metric ton, including all organic residue. So out of that, about 5% is coming from the distillery spent wash and the press mud, and another 25 is coming from 25 million metric ton of CBG production can come from the agri residue. So with this background, if we understand, if we enter into the, if the raw material is available, then we need to understand the technology part of it. So this is the biogas plant is a conventional biogas plant, or we all know the biogas is a very age-old process available in our rural India. But what makes it different when we bring it to the industry? So when we bring it to the industry, it has to be customized. It has to be high yield. Whatever the asset used, it should give the maximum output. So these are the important criteria requirement when we set up an industrial scale biogas plant, followed by purifying and then taking it to a CBG grade. So as you all know, we have bifurcated, or we have focused on the 4 unit operations. One is pre-treatmenting or the preserving the organic content present in the press mud through our proprietary microbial culture. And the second part is the biomethanation process, where we offer a flow reactor, which has a distinct advantage. So I'll cover it in the subsequent slides. And once the biogas is produced, the purification of biogas is equally important. So I would like to bring little correlation with your existing setup of a distillery and all, as you are familiar with that industry. Like the biomethanation process is a fermenter. Once the fermenter in a distillery, the dilute biogas is produced with maybe 8 to 10% alcohol. We need to purify it to bring it to the ethanol specification 99% concentration. The purification of biogas plays equally important in this case also. So likewise, once the biogas is produced in Western countries or in Europe, mainly these biomethanation plants are also called as fermenters. So in a similar way, after the biogas purification, the one more co-product which comes out of the digester is organic manure. So this organic manure formulation or fortification to increase its value plays a vital important to make these CBG, press mud to CBG project economically viable. So as I said, the press mud is a perishable material. And as you all know that in India, the sugar factory operates for 150 days. I mean, now we heard that even it can go up to 80, 90 days to 150 days. So it becomes very important to preserve the raw material throughout the year for a 360, 365 days of operation, because these biogas plants operation is continuous, because the CBG production or the consumption point is fixed. So we have to run these plants for a 365 days. So in such scenario, the raw material preservation is very important. So for that, we have a patented PM STAP process, where the volatile content on the organic matter of the press mud is kept intact, and it gives a consistent yield throughout the year. So coming to the next unit operation in this CBG plant is a biomethanation process. So there are, I mean, 2 to 3 types of reactors, which my previous presenters have already explained about it. So we are focusing on the flow reactor, where according to us, it gives an distinct advantage over the conventional process, where the HRT of the reactor can be kept constant and the conversions are much better. And also there are no any moving parts. So if you can see, it is like a it's like a swimming pool, and the raw material entering from this point will pass through the first reactor, and then it goes to second reactor and it exits. So if you see in a biomethanation process, there are two major distinct reactions happening. One is hydrolysis and acidification, which requires a different process conditions like pH, temperature, and all. And in a similar way, the methanogenesis process requires a different pH and temperature conditions. So this can be easily possible to achieve in this kind of reactors. So as I said, we can have a constant or a targeted guaranteed retention time possible in these kind of reactors. And with this, the mass transfer efficiency is much better, and the conversion of organic matter or the volatile solid present in this present in this feedstock can be converted for the better gas yield. So in this, you can see the graph. In case of the plug flow reactor, you can achieve a targeted standard HRT. Whereas in case of other conventional process, there could be a varying HRT. So which might result into lower biogas production. And there is one more possibility of short circuiting can happen in this kind of reactors. So that's the reason we felt that this kind of plug flow kind of a reactor will give a better yield and will work very well for this kind of press mud kind of substrate, or maybe press mud mixed bagasse or any other mixed feedstock, and even for the biomass. So, and the next process, as I mentioned earlier, so gas purification also plays a vital role, because once the gas produced has to meet to the IS specifications to OMCs or oil manufacturing companies to buy it and to sell it. Or rather, if the sugar factory itself want to use for their captive consumptions for their tractor trucks, but you need to have the quality as per the IS specifications. So in that, selection of gas purification also plays a vitally important role. We have come up with a different H2S scrubbing process where the chemical can be regenerated, catalytic process where the chemical can be regenerated, and we have a chemical H2S scrubbing process, followed by removing the CO2 from the desulfurized biogas. Can be done either with the chilled water scrubbing process or with the membrane-based CO2 removal system, and where the recoveries can be achieved more than 95% with the to meet the IS specifications, like more than 90%, or in case if there are no any other impurities, as high as 96% methane can be achieved. And the co-product which comes out, the digestate which comes out of the digester, is subjected to solid liquid separation. And then the manure which comes out is NOCA certified. And and the previous speakers already mentioned the importance of it, and it plays a very vital role in the economics of the CBG projects. It contributes about 15 to 20% of the revenue in the CBG project. So with this, we can further fortify this by adding few of the microbes or a few of the nutrients in this. This manure can fetch a better value, and we all experiencing, there is a lot of news around us that organic farming going which leads to improve the soil characteristics, or which will help the fertility of the soil. So under such scenario, this BioGreen NOCA certified manure helps a lot. So, and one more point I would like to highlight here is, as the soil or the fertilization process requires higher inorganic content in the manure. So as our previous process, like biomethanation process and even that pre-treatment ensures the complete conversion or the maximum conversion of the organic content to biogas. So we have less organic present in the manure, which will be more beneficial or helpful for the organic manure to consume it in the fields. So when we bring all these technologies, so we do all the proof of concept test and optimize all these parameters in our demonstration plant in our R&D center. We work for the different feedstocks. So like to begin with press mud, rice straw, wheat straw, and other feedstocks. So this is our CBG demonstration plant. And we would like to give you little background of our track records. We have set up almost more than 40 projects in biogas projects in India and abroad. So we have a good experience of operating these plants, what goes, though this plant looks very simple and all, but there is a lot of critical parameters to be monitored and operated. It needs expertise. And so we have built the largest plant in Thailand and India, where the biogas produced is about 5,000 nm³ per hour, which contributes to close to 40-45 tons of CBG equivalent. So next to that, when it comes to, this is all about the spent wash based biogas plants. Now we are talking about press mud based or rice straw based CBG plants. So we are executing 2 projects on press mud based, and we are executing rice straw based CBG project for HPCL. And we are also working on the spent wash based biogas purifying to make it to CBG. So this is our partner, which is DVO Inc. from United States. They have a reference of about 120 plants in US and Southeast Asia and Africa. The largest plant with this solid feedstock from the solid feedstock or the farm waste is about 3,000 nm³ per hour. So in terms of Indian conditions, if we want to talk, it close to about 30 tons of CBG final product. So I am just trying to correlate. So these are the few snaps of our India Potash Limited Muzaffarnagar plant, which is under commissioning, and the feedstock is about 200 tons of press mud processing. And we are also working with the Lifinity, the Nirani group, where 200 TPD press mud is processing, which is near Bagalkot, Karnataka. This is the biogas purification, storage, and the cascade filling photos. Just finally, after the biogas purified, then the gas is ready to use as a gaseous fuels to the vehicle. So compressing, filling manifold, cascade storage area, transportation, and then to the CNG filling station, and then final using it in the vehicle. So in the summary, what we discussed, what are critical for this press mud to CBG plant or bagasse to CBG plant is pre-treatment of the raw material is very critical. High efficient biomethanation process is critical, and then the robust biogas purification system. Because though the H2S content in this kind of feedstock could be up to 5,000 or 6,000, but there might be variation in this feedstock. So your process or the desulfurization of biogas should be robust enough to handle this variation. And then the last one is the organic manure or fortification of it to further improve the value of this organic manure. So with this, I would like to complete the technical part of this presentation, and I would request the forums or the bodies like STAI to make interventions required to accelerate the Satat program. So Satat program has been launched last 2.5 years now. But there are some hitches or the bottlenecks, which maybe the associations like STAI can, with the help of STAI, we can overcome this. The 100% offtake is not at there. Maybe take or pay arrangement, like in case of ethanol, whatever is there, maybe those kind of things have to be made mandatory for this sector to establish, or this sector to grow further. So FCO notification for liquid manure is still awaited. It is under discussion, but we have to take it up. And the extending the MNRE subsidy till 2025, or making it mandatory for the first 100 projects or maybe first 500 projects. So offtake of solid manure or liquid manure with a fixed MSP is required. And when there are a lot of investors project, or the project developers are coming, wherein they want to buy the press mud and to set up the plants, where the indexation of floor pricing of raw materials has to be made mandatory. And when it comes to rice straw and all, if there is a variation in the raw material price, the project viability or the project economics will go for a toss. So these things have to be had to be fixed. So, and like in other countries, or maybe there's a global practice of carbon intensity program, so which gives an incentives to the CBG producers, has to be given, or the pricing of the CBG produced from the organic waste has to be made differently. So those kind of carbon intensity program has to be started in India. And providing a subsidy to the material handling equipments required for press mud and biomass aggregation. So there are a lot of front-end loaders, tractor trolleys are required. So the equipments required for this kind of machineries has to be subsidized to make these projects more attractive. So with this, I conclude my presentation. Thank you.
Thank you, Mr. Basavaraj. On behalf of STI, we assure you that whatever points you have raised, we will take up with the government, and we'll try to take up and move ahead. Already government Satat program has already been introduced for all of us, and the government is very positive in giving us a good price of the CNG. Our last speaker, Dr. Sanjay, he has already given that the ROI is only 1.77. So I think with the present price of CNG, the ROI will definitely be good. One question I just want to ask you, that the digester which we are going to use for press mud, can it be used for other raw materials, like you said, rice straw, wheat straw, or corn shell, or grain distillery venasi? So can we use the same digester for all these things for producing this CNG? Can you highlight
Yes,
on
sir,
this?
yes, we can use.
Because this will help us in avoiding the storage of press mud for the off season. So that's why in the off season we can use other materials instead of press mud. Is it possible?
Okay. Yeah, it's possible. You mean to say whatever the press mud available during the season or during the campaigning time, press mud will be used, and during off season, other feedstocks or maybe like spent wash can be used. That's what is your question,
yes,
correct?
Yes.
Yeah, we can definitely use them.
Thank you. This will, I think, help in reducing the capital investment and the hazard of storing the press mud or any raw material. Thank you.
Yeah.
Mr. Goyal.
Sir, please unmute yourself. Goel sir.
Still unmute. Still voice is not coming. No, 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 no.
Yeah, no, it's okay.
Mr. Basavaraj, do you find any questions in your question and answer box?
No, sir, there is no question for him.
Okay. Fine. Thank you.
You can
Thank you,
move on to
Mr.
the next presentation.
for a
No,
very
thank you very much.
comprehensive presentation. And I would agree with Mr. Kesarwani that instead of storing press mud, which would require a large land area also, and also some expenses to for microbial treatment to avoid deterioration. It will be better if the conveyor which brings the press mud to the sugar factory directly feeds into the digester. It will save the cost of the material handling equipments like dozers and other things. And after the crop is over, then we use other biomass to run the same. So I think the focus should be on reducing the manpower. It will reduce the manpower as the handling cost of the press mat. First put it into the storage area, treat it, and then you use the dozers and other equipment to move that stored press mat to the digester. So it will become a project by itself. So it's better to have to move the press bed online, because in these days in sugar mills we are trying to minimize the manpower requirement to handle it, and we now have belt conveyors and in the process house to convey the press bed directly to the bins or to the lorries. So instead of that, we can convey the press bed directly into the digester. So you must think on those lines. And we know that a lot of biomass is available in the area around the sugar mills, including gas and other things. So that project should be should reduce the capex as well as the land area requirement as well as the manpower requirement to operate a bio-CNG plant. Thank you, Mr. Basavaraj, for the excellent presentation. Now we now move on to the next presentation, the fourth one of the day. It is
Sir, sorry to interrupt. There are a couple of questions here.
please answer. Please answer.
Yeah, they are asking what is the shelf life of the press mud. So with the technology, whatever we have with the pre-treatment process, we can store the press mud up to a year or so. So that is the one question. So we can preserve by adding certain microbial consortia, we can preserve the press mud for year. And the second question was, what is the typical area required for 10,000 TCD sugar factory? So 10,000 TCD sugar factory, I take roughly about 3 to 4% of press mud generation. It would vary as we were discussing sometimes before. But still, if I take 3 to 4%, around 400 tons of press mud is generated. And if you want to operate it for 365 days, it would be 200 tons per day processing plant. The land requirement would be in the range of 8 to 10 acres.
Yeah, and this land requirement can be substantially reduced if you don't plan for the storage of press mud for the off crop, and because land is a precious commodity these days. So this leaf nitty plant is based on what, storage of press mud for the off crop?
Yes, sir. Storage of the press mud.
Okay, and the India potash also is storing press mud for the off crop?
Yeah.
Okay, fine. Thank you, Mr. Basavaraj. May I now